Welcome to another parent-teacher video lesson from the earlygiftedmanual.com, a free website for homeschooled children 3 to 7 years old and their parents that promotes and develops giftedness at an early age. I am Gary Blank, the creator of that site, and your host and facilitator for this video and all of the videos in my educational program. As the video lessons are designed to work in conjunction with the program on my website, I ask you to, at some point, click on the URL link in the description box below, and this action will take you to the earlygiftedmanual.com. By doing that, you will be able to put this lesson and all of the video lessons here on my channel in the proper context of the total program that I am presenting to you and your child. Let's have a look at the bathroom scale. And the bathroom scale really has one use, and it's primarily for weighing people. And that's an important distinction to make. I'll talk a little bit about that, a little more about that in a few seconds here. But so it's great for weighing kids up to adults. So in other words, let's say you have a typical 5 to 6 year old or 4-year-old, anywhere from 40-some pounds to 50-some pounds as an average, all the way up to adults. And that's the range in which it works best. There are two types of bathroom scales. This is a dial scale, and it operates by a spring as weight is put on it, compresses the spring. And we also have digital scales that have a digital readout instead of a dial. So they're electronic, and they have electronic sensors in them to sense weight when it is placed on the platform. So two types of bathroom scales. And as far as accuracy is concerned, well, the bathroom scale is not going to be very accurate in the lower pounds range. Like, if you wanted to weigh something that's let's say 4 pounds or 7 pounds or 8 pounds, you're not going to get an extremely accurate measurement simply because the scale is not designed to do that. But when you get up into the higher numbers, over 20, and then especially as you go on and on, of course, the scale will be more accurate. So there's kind of a gap then between the postal scale that measured mostly ounces up to 2 pounds, and then this scale, which is the scale for weighing people, 50 or so pounds and up, around that area. And there is a scale that kind of fills the gap. It's called a kitchen scale, and you can certainly purchase one of those, or you may already have one, and those also come in digital and dial scale or dial varieties. And if you can get one, great. It will allow you and your child to do all the exercises you did with the postal scale, except with things that are a bit heavier. And their range, they're good up to, I've seen one that goes up to 22 pounds, another one 15 pounds, some not quite as high, but if you have one, you can do the same things with it that I did on this video with the postal scale. All right, let's talk about my particular scale that I have right here. It's a dial scale, and it measures pounds up to about, and you can see if you look on the other side of the zero here, up to about 280 pounds. And it has a zero adjust, and we talked about that on the postal scale. And this one, if you see my thumb right down here, there's a dial, and watch how it moves. And of course the red line is the indicator. That's how you actually read the pounds, and we'll get into that in just a second. That looks pretty good. Oops. It's an old scale. It's a little jerky. All right, so it has a zero adjust. And how do you read the dial? Well, it's sort of like reading a clock, because a clock is in effect a circular dial also, but it's a little bit different. But your child will need the same skills, and that is to skip count by fives and then count on. So for example, I'm not going to put something on the scale. I'm going to simulate something on the scale just by hand pressure. So let's say there's something on there that's like 17 pounds. Your child would have to look at that dial, and they know it's between 10 and 20, and then there's kind of a bold tick in between those, and that's the 5 tick. So they would say 10, and then they're counting by 5s, 15, and then they're counting on by 1, 16, 17. So that is the skill. If in fact you are using a dial scale, that is a skill that your child will need to learn to read the dial on the dial scale. So you can maybe a good thing to do with this scale is to weigh your child and then weigh yourself, and of course, you know, that will give him or her some practice in reading the dial, and you can compare those two weights. That'll be fun, and you can talk about that, and your child may have some questions about that. So that's a good thing to do with the scale. And a very cool project to do with the bathroom scale is simply to weigh your child, perhaps monthly, for at least a year, and even longer if you want. And then you can take that data and graph the results. So you could tie this in with a graphing activity, and your child can look at that graph and clearly see how he or she is gaining weight over time. So a really cool project that you can do with the bathroom scale is tying it into a graph. And I think at this point, I should say that you've seen a couple of scales here, and just like our linear measurement tools, there's a correct scale for the weighing task, and I think I've sort of made that point. Very light things, less than 2 pounds, you're using the postal scale. In between numbers, from maybe 2 on up to, well, I told you there's kitchen scales go up to 20, 22 pounds. You can use the kitchen scale, and beyond that, you could use the bathroom scale. And you can weigh things on a bathroom scale. Obviously, that's not its main purpose, but you can, as long as you place them on squarely on the scale, you can get a reading for reading on the weight of objects. Well, once again, it's bathroom scale not very accurate in the lower range. So now let's have a look at what they call the bucket balance. And this is one type of balance scale. This one has buckets, so you could even use it for liquids if you wanted. You could see there's kind of like a spout here and some gradations for measurements. We're not going to get into that. We're going to use it in a simpler way here today. But it is called a bucket balance. Sometimes there are just platforms here, and it's called a platform balance. And so, you know, the question is, what exactly is a balance scale? Well, a balance scale, first of all, as you can see, it's a very symmetrical apparatus, I guess is the word I would use for measuring things. It's very symmetrical. Both sides look the same and weigh the same, especially the arms here. And as you can see, these come off these two containers. And there's a fulcrum in here, and if your child is pretty advanced, you can explain how that works, how it's balancing on a fulcrum. If not, you can just skip it and not worry about it too much. And you could also tell your child that there's all kinds of balance scales that work on this balance principle. One of them he or she may have seen in the doctor's office, where you stand on a platform and they move weights around on a bar. That's a very fancy one that costs lots of money. So this is probably the simplest kind of balance scale that you may ever see. So I think the first thing you have to do when you're working with a balance scale with your child is to discuss this idea. What does it mean for the scale to be in balance? And to explain that, you have to explain the concept of equal weights on each side. So as you can see, it's empty now, and you know that the balance scale is balanced when these arms here are level, and there's a triangle you can see down here. The tip of it is pointing right to the indicator. And you would expect that because the fulcrum's here and they're identical on each side, so they probably, weigh the same or very close to it. But in case they don't, there's a nice little fine balance here you could use. That's this yellow thing, and you can move this back and forth. I've already done it to line it right up, but you can move this back for real fine adjustments, so you can get the point of the triangle right down that indicator, so you know it's perfectly balanced. So that's what I mean by equal or imbalance. And a good way to show that is I'm surrounded by all kinds of things here. I'll show you in a minute. Just to prove it, you can add one of our color cubes to one side, and look, whoa, straight down it goes. Is the weight on this side the same as the weight on this side anymore? No, of course not, because you've added weight to this side. And since these non-standard units weigh approximately the same, I'll put one over here. And that should, as we say, balance out. It's always going to rock a little bit like that. Balance out the scale. And as you can see, it does exactly that. So pretty amazing concept. And it shouldn't take too long for your child to understand that. Let's just put one more in each here. I'll do it on this side this time. What do you think's you can ask your child, what do you think's going to happen when I put this over here on this side of the scale? And hopefully he will say, well, it's going to go down, perhaps all the way down to the table here. And you put it in and almost down to the table. And then you could say, well, what do you think's going to happen when I put another one in over here? And if he's been paying good attention, he or she has been paying good attention, they will say, well, I think it will be in balance or level or equal. Those are all words you can use. And let's see if that in fact happens. I'm going to steady a little bit with my hands there. Pretty close. As you can see, there's some minor variations in the weights of these color cubes, but that's pretty much in balance. So that's the concept. That's the concept of the balance scale. And it's great for comparing the weights of different things. And let's do that. And I think a good way to start would be, I'm going to take 2 balls. As you can see, one is much, much bigger than the other. This black ball is a smaller one, and this one is, the yellow ball is a bigger one. But I know that this ball is hard rubber or plastic rubber. I think it's rubber. And this one is a foam ball. So I know that ahead of time, but you could show your child these and you could say, well, which one do you think is going to be heavier? And without letting him actually feel them, let him guess, and he or she will probably say, well, this one, it's bigger, right? Well, let's find out. And as you can see, the smaller ball is heavier because, as we talked about earlier in the lesson, it's more dense. So that's another word you can bring up, and your child may or may not understand that, but there's probably a way you can explain the concept of density to them. So that's a good example to start out with, isn't it? It's bigger is not always heavier. Okay, let's see. Let's try we'll keep this ball, and we will bring in my juggle ball, which is full of some kind of fill, whatever it is. It might be rice or something like that. Who knows? Or little plastic pellets. And at this point, you could, give your child a little break, and you could have them pick these up one at a time if they want and guess. And then finally, you can put one in the bucket, and of course that side's going to go down. Put this one in, and look, the juggle ball is definitely heavier than the rubber ball. Probably because I don't think it's as dense, but it's big. It's much bigger than the other one, so it weighs more. So as you can see, this balance scale is just a way to compare weights. Let's see, what else do I have here that I could show you? How about let's bring in this giant black foam ball, and let's measure it up against the juggle ball. Wow, look at that. Juggle ball, even though it's much smaller, weighs more because it is dipped down almost to the level of the table, and this one is higher. So lighter one will be higher, heavier one will be lower. And on we go with this. What else could I grab here? Remember how we weighed my wallet and the cell phone and realized that those were pretty close? We weighed those on the postal scale. Well, let's put the wallet in. Let's put the cell phone in. And look, I was right. They are pretty close. They're not exactly equal. If you look at the indicator, it's not exactly on the line down here. The point of the triangle is not exactly on line, but pretty close. And then you could do some fun things like this. You could say, well, what could I add over to this side to make the weights equal? Because this is obviously heavier. It's sitting lower. And let's see, what do I have here? What could I use? Maybe a quarter. I'll put a quarter in over here. Oh, and as you can see, cell phone and a quarter is about the same weight as my wallet. So anything goes. You can try all kinds of different combinations here in these buckets. And I could go on all day. I'm surrounded by things here, but you get the idea. It's just a great way to compare weights and give your child an idea of what things weigh, how they compare to each other. And I think the last thing I want to do here before we go into a different exercise is to, let's see here, what do I want to do? Oh, I know what I want to do. I want to show you that I'm going to put this really nasty dinosaur here, this T-Rex in here. And then I'm going to go to a non-standard unit. And I'm going to say, well, actually this T-Rex might be a little bit too heavy to use. I might have to use something else. Let me use my toy car here. I'm going to put this in one side. And then I'm going to use a non-standard unit like the color cube. So how many color cubes will I need to equal the weight of the car. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, we're getting close now. 13, 14. So 14 is a little too much. 13 is a little is not enough. So you could approximate, and we've talked about that with when we were talking about linear measurement. So it's about 13. The toy car is equal in weight to about 13 or 14 of the color cubes.